Thanks for inviting us to give this presentation today. Thanks for the introduction, Pete. We're going to sort of do a bit of a double act. So I was going to introduce the work, and Jianxiang will continue with the specific project that we're talking about. But I thought it would be useful to give you some background. Some time ago, Pete got in touch with me and said, could we predict urban temperatures now and into the future? And I've been working with Hong Kong University and with Jianxiang for some time now, probably 6 or 7 years on various modeling projects, mainly concerned with the urban scale. We said, right, well, yeah, we sort of could use the Wales project to show something as a case study for our modelling. So just to give you some background as to what we've done in the past, which leads on to this project. I'm trying to sort of, right, how do I... Oh, can you put the slide forward, Jianxiang?
Yes.
We've been looking at urban scale modeling for some time, and in order to do that, we need to be able to simulate the urban scale built environment and also the outside environment. So we can simulate buildings and their energy performance, their environmental performance, the temperatures inside buildings. But then we extrapolated from that to look at the temperature and the environment outside our buildings and the interaction between the buildings and the outside environment, mainly to look at outside comfort, but also to look at the impact of the local climate, the microclimate, on energy performance. And one of the main things that we've been looking at is pedestrian comfort. So next slide, please. One of the projects we started with was to see if we could, if our models were predicting the right sort of temperatures outside. And we used this facility in Guangzhou. It's like a concrete city. These blocks are intended to simulate a high density urban environment. And they have various temperature probes on the surface and on the spaces between them. And we could use this to test our model to see that it was giving the right sort of answers at this sort of scale, which is okay. I think it's the scaling is okay at this size. And you can see people in the background there. So these blocks are not quite as tall as people, but nearly. And we were getting some encouraging results on the comparison of measurements and predictions. Next slide, please. We then went on to model the outside environment in more detail, and we took this area of Hong Kong, Singin Pun, and we combined the energy model developed at Cardiff and the urban climate model developed at Hong Kong, and we combined these models so they exchange data at a regular time step of an hour, and the energy model provides the data on outside surface temperatures, and then the climate model takes those surface temperatures along with meteorological conditions from the local weather station, and we can predict the variation in temperatures on this particular urban block. And again, we were comparing measurements and predictions and got some encouraging results. Not only did we look at the weather data, but we also looked at the anthropogenic heat gain from traffic exhaust, and later on looking at the green and heat gain from the buildings themselves, the air conditioning systems, and restaurants within the urban block. Next slide, please, Jianxiang. And this is expanding that to look at all these heat gains to the outside environments. Most of these, the modeling is looking at heat gains to the environment, but we also looked at the impact of green areas and trees on mitigating the urban temperatures. And we did some interesting modeling then to look at the various impact of different types of features of the built environment and their impact on outside temperatures. So we can see the bottom right there that greenery in itself has a limited impact, minus 0.3 degrees. Tree canopies provide shading, and that has a bigger impact, reducing the equivalent temperatures by 1 degree. If we can reduce anthropogenic heat gains from traffic, air conditioning systems, exhaust from kitchens, we can get an average of nearly 2 degrees. Trying to direct the breeze through our buildings, producing comfort cooling, can give us nearly 2 degrees of perceived heat temperature reduction. And then things like water sprays, evaporative cooling give us more. So I think that's an interesting graph on the bottom right there, but it is for Hong Kong. And one of the things we've been discussing recently is, could we produce this for Cardiff or cities in the UK? Thanks, Jianxiang. Perhaps. Also, we've been looking at other aspects of the built environment, and we published a paper a couple of years ago now on using these models to see if we could predict the spread of infectious disease throughout the city through external pathways. We know that there are internal pathways for the spread of infectious disease, but we suspected that there could be outside pathways with the air being exhausted from one building to another. And we got some good correlation between our predictions and our observations of the spread of SARS and COVID in these high-density, high-rise urban environments. So that's another aspect that we've been modeling. Next slide, please. So I'm going to hand over to Jianxiang now, because he will explain the way we assess comfort using the UTCI, which is an equivalent temperature. So I hand over to you now, Jianxiang.
Yeah, thank you, Phil. And thanks, Pete, for the invitation again. I hope you can hear me all right. Following Phil's introduction, these are expenditures of the simulation on human thermal comfort in outdoor urban spaces. These are field work actually carried out, I think about a decade ago in Boston, Massachusetts, US. And then we are collecting field measurement data on mean radiant temperature, for instance, the radiative energy from the sun, from the atmosphere, from solid surfaces. We're also collecting human subject data on people's perceived thermal sensation and comfort through the iPads, also through skin sensors, and also questionnaires, etc. So these are verified using the instruments and peer-reviewed scientific publications. And then we would like to bring you to an application of these modeling tools in 3 cities that really is near and dear to many of our audiences in Wales. We're looking into the prediction of future and current heat waves and its implication, especially on the pedestrian scale, assuming there's people using the streets, parks, open spaces on a daily basis. What are these predicted impact on these individuals, rather than, let's say, for the air temperature or the surface temperature assessed at the remote sensing scale? So we delved into the methodology using a combination of modeling tools using input data from the Welsh government, from NOAA, from a variety of other sort of tools that to generate future weather, also to review of statistical previous meteorological records. We've also using combined simulation tools and then also using validation studies based on field measurement and Landsat, land surface temperature data, etc. In the interest of time, I will briefly walk you through these 3 cities. Then first, we're looking into Cardiff, Wales, the largest city, and this is a square kilometer, a digital twin, as we call it, of the thermal properties, including the 3D geometries of buildings, built environment, pavement, vegetation, particularly tree canopies obtained from the official database. And then we'll be able to run the model. And this is one example of the wind flow, the wind speed at a pedestrian scale, 1.5 meters. It's roughly the height of a human shoulder, walking, let's imagine walking on the streets, cycling, etc. And these are predicted equivalent temperature measured in UTCI, which is a terminology for Universal Thermal Climate Index, basically telling you to give the same perceived thermal sensation. This is the air temperature that is needed to achieve the precise level of heat stress. So that gives you a 9 o'clock prediction from left to right. This is from historical 1981 to 2020, and then 2050, and then further to the right, we have 2080. And then these pixels are, each pixels, I think is about 3 or 5 meters. And that represents the particular hour. You can see that respond to the shading of the buildings, the solar angle, and the vegetation, tree canopies in particular. So as the sun rises, you would be able to look into the rising heat stress, and that's on a typical sort of a hot day on August 27th. And particularly you see the rising heat stress in the future, 2080, that usually goes into the pink zone. That's actually is about 30, 35, or even further above, which is really stressful, and sometimes it's detrimental to health and well-being overall. And then the sunset, you see the heat stress alleviating slightly. And then we repeat this procedure for Newport, and you were able to see the similar results in consistency starting from 9 a.m. in the day, and then the heat stress gradually rising, and you see the same consistency in future heat stress as the sun keep rising and the temperatures start to build up all the way till sunset. And same for Wrexham, we repeat the same procedure, and then you're going to see a consistency in results as the trend also indicating a very high temperature for those cities that we used to be very familiar with. And then if we land in terms of the implication, that really leads to some of the recommendations, what can be done. I can walk you briefly in the interest of time. And one of the most important lessons we can look into is the disparities in the simulated results. That you would see that the cool spots usually is under the tree canopy cover versus the hot spots. You have the pavements, hardscape pavings, concrete or asphalt, and that usually actually increase heat stress significantly. There's second implication, looking into the urban form or the orientation of streets, the organization of buildings. Typically, we find the cooler spots in the east-west oriented narrow alleys that provides shades and also channeling the breeze happening to the westerly wind, in particular in the summer season. The hot spots is found on the north-south oriented streets. Usually these are wide streets. They're just perpendicular to the wind, so it stagnates the airflow but at the same time, it cannot shield the direct sun when the solar angles are high in the middle of the day. And we found, that's one of the serendipity of discovery, we found this traditional arcade that are the historical heritage that can serve as potential cooling venues. If they are naturally ventilated, you have the cool breeze seeping through, and then also they shield pedestrians from direct sunlight. These are potentials to be used. We're right now working on extensive evaluation studies based on field measurement. So this is one measurement spot. We have on the ground equipment measurement of temperature, and then we're comparing temperature and prediction and measurement and showing promising results, as this is one of the preliminary work that Phil and I are continuing working on. We're also bringing this model to another familiar location to maybe some of the audiences here. This is the Greener Grangetown, not far away from the square kilometer at the center of Cardiff. And then we're going to test the model to see the cooling impact of the vegetation, the tree canopies, and many of these much celebrated and very highly publicized project, and then discuss the potentials and whether we can harness the cooling benefits and perhaps to maximize it through a good combination, and also to sort of to allocate resources wisely. I think we're going to end the presentation on 20 minutes or 1 minute over, and we'll be really happy if there are questions and discussions and comments. Thank you again.
Well, thank you so much for that, Jianxiang. That was a race through some quite amazing research that you've done. The computing power on that just boggles my mind. We've already got Aleka who'd like to ask a question. Can I ask you to unmute yourself and turn your camera on if you can, Aleka, and ask your question?
Yeah, no problem. Sorry, I'm just connecting my camera. Can you hear me okay?
We can, thank you, and we can see you.
Okay, great. And my question was just about, because just for context, I work for the railway, and Cardiff Central is one of the area that we look at. But I just wanted to check, so we've got some weather stations, and during the heat waves in the summer, we noticed that the temperature didn't drop throughout the night, so the temperature stayed quite high, whereas obviously you'd expect it to drop, and then that kind of process happened. So I was just wondering, with the modelling that you did with the heat, is there any way that you can kind of factor in that as well? Because obviously a lot of them, the temperature drops in the morning and then goes back up in the day, and that process is redone. So when you're looking at the future scenarios, can that be modelled in as well? With so the temperature's not dropping in the night. I hope that makes sense.
Yeah. Thanks for the question. I like I think that's a great implication. We noticed that the warm nights, especially here in Hong Kong, is more detrimental to health when people are trying to get some good sleep at night. But the hot weather really is preventing them from doing so. And to answer your question, yes. The model can indeed run through the 24-hour cycle, or sometimes run through the entire annual hourly cycle to computing continuously for every hour for a designated area. And then that would indicate the sort of, or to capture the warm nights phenomenon as you captured. And then sometimes that's associated with perhaps the cloud cover, perhaps the extent profile, the temporal profile of the heat wave. And then that's really sometimes going to impact people even more sort of severely in terms of disturbing the sleep patterns. Phil, I don't know whether, feel free to add.
Yeah, it's a question we were asked last week at a presentation. Can we simulate the night temperatures as well? And I think yes, we can. Perhaps we don't think of it as so much of a problem in the UK as in Hong Kong, but it is an issue, yeah. So that's something that I think we can extend the model to do quite easily, yeah.
I wonder, could you put up the slide again showing the temperatures in any one of the cities at about 4 o'clock in the afternoon? Because I think that's when they seem to stabilize at their highest.
Yeah, that's right. So,
And I remember that certainly in Cardiff, some of the areas were starting to warm up quite a lot at 9 o'clock in the morning. I think they were around about, there was some that seemed to be somewhere down near the railway station or the bus station. So you can see where the temperature is building up the most, and it does seem to be in those dense areas. But where it heats up first is where the sun strikes first. And I don't know if anybody's had the misfortune to have to wander around on a glacier in the middle of the day. That's something as a mountaineer I do. And so you're on this river of ice, maybe a kilometer thick, and you're absolutely cooking because there's no shade. You're standing on ice, and the thermal temp, the physiological equivalent temperature is crazy hot. So you can see the river is showing as being very hot at that time of day, simply because there's no shade. Right, I've spoken too much. Katie Metcalf, you've got a question. Can I ask you to unmute and turn on your video if you can?
Hi, thanks, Pete, and thank you very much. What a wonderful talk, really exciting model. What would it tell us about what type of green infrastructure we need to be aiming for? Because I can understand now why wide streets, especially north-south, aren't very good. But is there a way we can put types of street trees in, and what types of street trees, and should we be going for continual canopies? Have you done any work on that side of things?
Great question, Katie. Maybe I can get started. I think Phil has some brilliant points to make. Regarding to the implication, I think definitely the model can test every species of trees with the canopy cover, with the leafing area. There's the species-specific parameters we can test. That's definitely that's the yes. Regarding the cooling benefits, we've been also trying to test. I think Phil showed the slides earlier that we have a variety of measures beyond tree canopies, as simple as such as managing the anthropogenic heat from buses, from AC units, from their people's homes. Or sometimes you have mechanical fans or the water spray, very fine water particles. And it's been done actually extensively in Hong Kong and in Singapore, those of the tropical climates. And then we found some of these measures would work very well, especially under the study conditions. So our suggestion is that we have tiers of solutions, the toolbox, ready for really depending on the geographical location, the climate pattern, or so the density of the cities. So these are critical factors would go into, let's say, decide which sort of items from the toolbox will work the best. Of course, there's also a cost-effective equation to be taken into account. For instance, some of these measurements could be expensive in terms of energy. The water spray would require a supply of clean water, and that may not be readily available in some dry areas. So these are also some sort of levels of custom-made solutions for individual locations. Thank you for the great question.
Can I ask a quick follow-up, Pete?
Yes, please do. And then we'll turn to Joanna and then Neris.
So I noticed on the time series that by 2080, the trees seem to have less impact. Is that just the sheer level of climate change by then?
Well, if you're referring to sort of the comparative reduction of the mitigation absolute cooling terms, I think that would explain in terms of the changing temperature. The temperatures are supposedly higher. and then possibly humidity, because for the most of the climate model would predict the future weather would be warmer, would be more humid, more moistures in the atmosphere. So I think these are conditions that are actually driving many of these increases in heat stress rather than, let's say, the solar radiation alone. Yeah, that's a great question.
Thank you very much. It's been great talk. Thank you.
Thanks very much. Joanna, can I turn to you now? I'll ask you to unmute and turn on your microphone. Hey. Oh, Joanna, we still can't hear you. I'm sorry about that. I'm sorry, we still seem to have a problem with your audio there. Perhaps you could type your question into the chat, and while you're doing that, I'll turn to Neris. So Neris, if you could unmute.
Hi there, thanks. Thanks, this is really, really helpful. I'm currently working on a health impact assessment of climate change in Wales, looking at both the determinants of health, which obviously includes the sort of built and natural environment, but also different areas in Wales, different geographic communities. So I'm really interested if these findings have been reported in any journal papers or reports yet. That would be really helpful. And secondly, I'm interested in maybe how these findings could be applied to the population that live in these urban areas, particularly. So whether there's, certain areas with more young children who we still want to be able to play outside safely, how it could be applied to, considerations of design for urban green spaces to make sure that people can still be physically active, safe outside.
Thanks for the question, Neris. I'll be happy to send you the publication. If there's a certain way that I could bother Pete to arrange with our email contact, I'd be happy to send you the publication and papers. Many actually were already out there. As for the second question, yes, I think I can think of two examples of applying the research I use of our local cases. The first is working with development authorities. For instance, we're working with Hong Kong's Urban Renewal Authority, and more recently, Singapore's Urban Renewal Authority, in terms of deciding the appropriate building massing, the master plans, where would you leave these breezeways, the gaps to allow the sea breeze to penetrate through the dense urban fabric of Kowloon, and then how would you optimize sort of the green spaces, the locations, to sort of on the side to optimize their cooling benefits. So the models have been connected with more of these mathematical tools that can sort of guess through hundreds or even thousands of solutions. And that would just leave perhaps about 10 or 8 the optimal solutions to the table of experts who will be ultimately making the best decisions for the communities. Of course, we can tune the model to fit into the prediction, the physiology of young children, or the elderly, or women, or sort of the demographics have their impact. A second implication, actually, we've been using some of the models to test the suitabilities of predictions, public warnings. For instance, we're working with the Hong Kong Observatory for sort of the choosing the right thermal indicator about what kind of a day that's suitable for outdoor activities, and what precautions should be the members of the public be taken before going out for adventure. So these are sort of more of the passive, out of choice. The climate has already changed, and then how do we cope with or live with it? Thank you.
Thank you. That's really, really helpful. Really appreciate your answer. Thanks.
We've got a question in the chat from Tom Johnson. He's on a bus, so he can't ask it directly. But he asked, has this modelling been done on any smaller towns, particularly in any rural areas? He's wondering how small towns like Brecon, Llangollen, Machynlleth will respond to climate change.
Yeah. Yes, the answer is yes. I think I remember we tested on a smaller city in Jianxiang province in coastal China. It's called Yueqing. So we're working with a real estate developer, sort of affiliate with the CP group. And then we sort of applying this model to indicate sort of the severity of heat wave during the various climate change scenarios, and how to sort of use this findings to optimize or find appropriate planning or design solutions. Yes, indeed, it can be done. It will show that the built environment indeed can modify significantly the heat profile, affecting the residents' life and perception of comfort.
Thank you so much for that. We've got David's got his hand up. I wonder, David, could you unmute and ask your question?
Hi there. Yeah, my question was about the pathway selected, because I'm particularly interested in the very long-term impacts of climate change. To what extent were other pathways considered? And my feeling is, and we're probably going to do a little bit of research on this in the next year, but previous modelling is consistently underestimated the extent to which negative impacts are occurring. In other words, has the pathway you've chosen potentially underestimated what might be happening at 2080, let's say? Because if the modelling from higher pathways shows that the temperature goes up to 50 degrees, you know, then we need to be talking about, well, people are going to be dying unless we do something. And not that I want to be alarmist about it, but surely that has to be, or one would feel that was within the possible range of outcomes.
Great question, David. If I understand correctly, the pathway you're referring to in terms of the high or low choice. I remember this is based on the future weather profile of the IPCC A2 scenarios. It's a bit modest. So we haven't picked the extreme ones, as you mentioned, for the reason that we think that probably there's a certain range. But I think you're absolutely right that some of these models maybe underestimate the severity. And that probably indicates maybe the next ladder of the tiers of tool sets available to us. We probably need to adopt more of these tools or try multiple strategies at the same time in order to gain the cumulative protective effects for our people living in cities and towns.